Hello everyone, welcome to the weekly wrap. So it's Friday morning, the 2nd of February, and I'm just going to wrap up what we've done this week, try and remind you of the most important issues, give you some top tips, and very briefly introduce next week's session. So just to remind you, to get the materials, you need to go through the 17C VLE site. You go to Term 2, Data Analysis in R, and then you follow this orange blob of joy. So we want to go to week 4. So the materials here you can see are organised by week. We're in week 4, so I'm going to follow this one here. And this page is the base, if you like, for all of the week's learning materials. So as I mentioned before in the lecture, I think these materials are quite closely integrated. So we have a lecture, a workshop and independent study, and I think you need to do all three of them to meet the learning objectives for the module, or for the week. So we have on here not just the practical exercises that we do in the computer workshop and the learning objectives and so on, but we also have the slides from the lecture. And they're in PDF format, which I think is ideal for referring to if you just want to remind yourself of things when you're in the practical or for some other time. But I've also got the PowerPoint presentations here as well, because I know some people like to download these before a lecture so that they can make notes on them in the lecture rather than using a PDF to make notes. So if you want to do that, you're going to need to go to the base page for each week. So the key things this week, the learning objectives were about distinguishing between response and explanatory variables and their data type as well, whether they can take continuous values or they take discrete values, and also to understand more about the logic of hypothesis testing and that you should be able to explain it with an example. And I used an example in class which was on the effect of poverty on birth weight. So those two learning objectives are really met by the lecture, so you want to go over the lecture slides if you haven't quite got to grips with those, whereas the second two were much more met in the practical, although we did cover some of these ideas in the lecture as well. And I think later on in practicals, in weeks, you'll see that the overlap between what's in the lecture and what's in the practical is much greater. So you really do need to do both to meet the learning objectives. Okay, so the fundamental ideas that we needed to get to grips with in R were about reading in data, creating summaries and doing plots using the manual, and then being able to get those into Word. Many people could do that already, I think, using Word. So the thing about reading in data, the key point was that you need to understand paths. Now, paths is something of a threshold concept. It just says where the file is. So when you read a file in, you need to know not just what the file's called, but where the file is. And this is such an important concept, and it's something that can really hold you up later on and delay your getting started with work when it's not really the actual statistics or the R that you're having trouble with. You just don't know what a path is. You don't know how to get your file into R. So I've actually stuck a video in at the end of this practical from last week. So if paths are a little bit mysterious to you, there's an extra video here to watch. Let's just go back there. Don't really want to see that, do we now? So if by watching that video, perhaps going over what I said in the lecture, and by going through this workshop, paths still don't make sense to you, please do talk to me in the lecture or practical and I'll have another go at explaining it. Or my demonstrators might be able to explain it. So I think you will get it. It's not that hard, honestly. And once you do get it, you'll think, it's obvious. But it's sort of a light bulb moment. So that's reading in data. And when you read in data, it reads into a fundamental structure in R, which we call the data frame. And a data frame is just like a rectangle of values, where you have variables in each column, and each row is a case, or an individual, if you like. And to refer to values in a data frame, you have to use this $. So we're using, if we want to use the variable interorbital in this case, that's inside the data frame pigeon, we have to say pigeon $interorbital. And I guess in a way this is a little bit like the paths thing. It's not enough just to say what the file name is, you also need to say where it is. And it's the same here. It's not enough to say what the variable's called, you also have to say in what data frame it's appearing. So this is the whole variable's name, if you like, pigeon $interorbital. The other thing we touched on here was to do with tidy data. So tidy data means that you have variables in each column, cases in each rows, and you don't have multiple individuals on a row. So we had an example where we looked at the interorbital distances for two populations of pigeons, A and B, and I supplied the data originally in a format where you had them in two separate columns. And this isn't what we call tidy because we've got two individuals on one row. Okay, and there's nothing related about these individuals at all. We could happily reorder these values, they've got no relationship to each other at all. So to make this data tidy, we need to stack it. And that's very simply done with a function called stack, in order that we have data where we've got all the values in one column and another column which says what population they are from. So the next top thing that you need to make sure that you understand from this practical and from last week's practical, I think, is about using the manual. So last week we had some independent study. If I go to the bottom of the page here, you'll see that in every practical or every page we're going to have the objectives from the previous sessions. So here are the objectives from the previous sessions, so you should be able to remember which session you learned something in, and then there's a link to the session to help you find it again. And the independent study for last week's, or one of the independent study activities, was about getting help in RStudio. So watch this video on how to use the manual. Okay, so now I'm just going to give you a few top tips. When you're working in R, you want to make sure, just going to run some code here, get some clean. Make sure that you always use a script. Okay, so I'm just going to get rid of that bit. If I want to know where I am, I need to write a command getwd. So if I run that, you can see that this is running the code in the console, and it's much better to type in the script than it is in the console, just because then you'll have a nice record of everything you did that worked rather than every single thing you did, which, if you're anything like me, is mainly rubbish. The other nice thing about a script is that you can have as many comments as you like. So I've got where am I here, and you can see as it's running here, R knows that that's not a command, it's ignored it. It's just because it's edited. So to give you an idea of what a well-commented script looks like, in every practical, like this one here, I have a script example. So this is an example of the sort of script you might come up with by doing the practical. And you can see that you can use these hashes to make quite a lot of formatting. I'm just going to show you this in R because it makes it look a little bit clearer. So you get the coloured writing. Here we go. This is the same file. So, as you can see, most of what's in this file is actually green. So it's nearly all comments. The amount of comment compared to the amount of code is about 10 to 1 or something like that. So you can write as many comments as you like, and these extensive comments will really help you not just learn the commands, because it helps it go into your brain, but it means that you'll be able to find how to do things more quickly later on, okay, from scanning over your documents. So you write as many comments as you like, and you can also record in here decisions you make when you're doing analyses about why you went on to do something else. Okay, so it helps you remember not only what the code does, but why you did it and why you chose to do some things over other things. Now, my other top tip is to use spacing. So at the moment it might seem that whether or not you have a space somewhere is a little bit arbitrary. It's not, and the rules will start to become, or the patterns will start to become more obvious to you. You can't have a space in the middle of a command name, so I can't put a space there. I don't want to have a space really between a function and its brackets. Don't want to have spaces in variable names, like that. That doesn't work. But I can have spaces around any operators, like an equals. After commas, I can use indentation and so on. And I highly recommend indenting your code like this. And this is going to do this automatically for you. If you press enter after a comma, it'll automatically indent the code. And then you can see all of this code is part of the same block, and it will run as one block, but it's much easier to read than if it's all on a single line. Okay, so these example scripts that I've got on the end of every practical are not supposed to give you, or not designed to show you all the answers. And of course some of the answers aren't coding, they're about thinking. What is though, is the RMD file. So the RMD file has every single thing in it that I used to do the practical. So this script here, this is what I use to actually produce my web pages and edit them. So they both have all the code that's needed and all the ideas. And you can find, so here for example, there's something marked coding answer, which means this is how you found the 14th value in that column. Okay. So the code doesn't appear in the HTML, but it is in the RMD. So although the answers are there, I strongly recommend you not just copying and pasting from the RMD file. I know it's tempting, but you will learn much more if you can try and solve the problem yourself, or even if it involves asking somebody else and they just tell you the answer. I still think you'll learn more doing it that way than you will just going straight to the RMD file. Okay? So try not to just copy and paste text that you haven't written yourself. Okay, so then just finally, let's have a quick look at next week. So next week we're going to be doing chi-squared tests, and you'll be glad to know, or some of you might be glad to know, that we're going to be doing these in a workshop by hand. So this is a pen and paper workshop. You can see the learning objectives here. So this is because chi-squared tests are often easier to do by hand actually than on any kind of computer. And I would really use this time, because you're not going to be asked to learn more R, because you don't have to learn more R this week, I really would use this time in order to practice the R that you've learnt already. Just if you can really get that base solidly, that will really help you. I've tried to make that learning curve at the beginning a little bit less steep, but obviously as we move on, I start to make more and more assumptions about you having got to grips with the stuff that you've done earlier. So definitely go back and do the first practical. If you've already missed both practicals, it's not too late to go to the practicals from the start. If you didn't come into the workshop, you can come to the workshop and just do the first one, even though everyone else is doing the fourth one or whatever. That's fine with me. Just do what you can to learn it. Okay, so I'm going to say bye-bye and have a nice weekend, and see you Monday.